Alright, so what I'm doing is stealing our notes from section 11.1.4 and to piggyback them for these problems here. So number 34, welcome back to your exam review. I think this is close to the end. Transform the given equation from rectangular, remember those are x's and y's, to polar form. You're not done until you have r equals some stuff. Well, here's our little formula, math weapons. So we look at the x. We don't want x. We want to get rid of rectangular form. So what does x equal? R cosine. So we go 2r cosine theta plus 3. What's y equal? R sine equals 10. Don't think too hard. Remember the rule. Polar form, got to isolate r. So we got to take an r out. We're left with 2 cosine theta plus 3 sine theta equals 10. So we got to divide this side by 2 cosine theta plus 3 sine theta. And we got to divide this side by 2 cosine theta plus 3 sine theta. Running out of space. So r, this is gone, equals this. Let's go to this one. Got to be on the hunt for this. After you've dealt with these a long time, this jumps out at you because x squared plus y squared equals r squared. So that was easy. So r squared equals, and then we got this y, which is r sine theta. Now don't forget, we're trying to get r equal to some stuff. So I'm going to subtract r sine theta. Subtract r sine theta. These are not like terms. I'm going to spin it around. So r squared minus r sine theta equals 0. Better use a piece of paper here, running out of space. So what I'm going to do is take an r out. I get r minus sine theta equals 0. Remember, this is a situation. We have two situations. R equals 0, and then this stuff equals 0. So we're going to solve by adding sine to both sides. So we get r equals sine. There's an answer. There's an answer. But in this world, r stands for radius. Your radius can't be 0. So therefore, this is your answer. Kind of a strange situation, but that's what's up. Now we're going to do things the different way, backwards if you want to think of it that way. So let's take a look at this. We'll get started. And so now, r equals 3 cosine theta. Now, we want to get rid of that, and we don't want that in a rectangular form equation. So, what do we want? We want r cosine. So what are we going to do? We're going to multiply this side by r, but if we multiply that side by r, we got to do the same thing here. So that would give us r squared equals, now does it matter where I put the r? Not mathematically, but for my brain, I'm going to put it right next to the cosine because r cosine equals something. It equals x. So this, and what does r squared equal? Well, we just figured that out. It equals x squared plus y squared. So we're going to replace this with x squared plus y squared equals, what does that equal? Well, we just said that equals x. And you can be done. All right. Next problem. All right. Pause this a second. Okay, 35B. Got a definite twist in this one. So, if we get started, and we're just looking at this thing, this is jumping out at us, and just by almost habit, we sure would like an r there, because we know that r sine equals y, so that's kind of the trigger. So, but we can't just multiply one term by r, we got to multiply everything by r, which is going to really introduce a twist here. So here we go. So, that times r, 0. This times r, negative 4r sine theta. Now I'll get to that in a minute, but then r times 4 is 4r. Now this is where you're going to be confused, because there's something new that happens, but just relax, breathe. Rectangular form means no r's, no cosines, no signs. We only want x's and y's. We don't care what they look like, but those are the rules. So let's concentrate on this because this is pretty easy. What does our sine equal? Well, according to our little formula, our sine equals y. So that's easy. So we know this is just y. So we get negative 4y equals 0. Now remember, we're not solving for anything. We're just transforming one equation into another equation. So we go, well, wait a minute. What do I do with that? Well, there's a little twist. Remember, r squared equals x squared plus y squared. We're in this whole game of substitution. How can we find r? Well, if we take the square root of that side, take the square root of that side, we get r equals the square root of x squared plus y squared. And that's what we're going to substitute in for there. So we had to manipulate this a little bit to work a little bit harder for us. So that's why it's a little different. So we're going to replace that with what it equals. 4 square root of x squared plus y squared. Strange looking answer. But what'd you do? You got rid of your cos, you got rid of your sine, you got rid of your r, you introduced x's and y's only. So you did the job, even though that one was tricky. 36A, look at guys, last page. Give yourself a pat on the back, almost there. So this says, write the polar form of the given complex number. So remember, by definition, complex numbers a plus bi. Polar form, another word for that is trigonometric form, and here's your formula. So z equals complex number, a plus bi, z equals trigonometric form. Now, what are these pieces? Well, remember, that's our r, length of our spinner, radius, what have you. This is how far you spin your spinner to get to that coordinate point. So, with that in mind, we're just going to plot that point. So, negative 2, and then up 2i squared of 3. So, that's essentially 2 square root of 3 up the imaginary axis. Remember, this is my x, this is my imaginary, so I can connect the dots, and I should make a connection. This times the square root of 3 is this. You know what that means? This is 30, that means this is 60, 90, and if that's 60, that right there has to be 90 plus 30, or 120, which is just 60 times 2, so that's 2 pi over 3 if we're going to go with the radians or degrees, whatever they want, be able to adjust. So, what's our r? Well, if my short side's negative 2, remember my hypotenuse is never negative, so that's going to be 4. That's my r. So it'd be 4 times cosine of 2 pi over 3. Yeah, we could put 120 in there. Plus I sine 2 pi over 3. And we're done with that one. Let's go to this one. So this is just a coordinate point. I know it looks weird, but we go left 5, and then we go up 5 along the I-axis. As you can see, these two sides are the same. So that's 45, 45, 90. So that's got to be 5 square root of 2, just following the rules. So that's my r. So that is 5 square root of 2 cosine of however far I spun my spinner, which is 135, but if they want radians, that's 3 chunks of 45. So that's 45 3 times. So 3 pi over 4 plus I sine 3 pi over 4. Done. All right, so number 37, it says write the rectangular form of the given complex number, use exact values. All right, so this is just these problems go in a different direction. So this is telling you what your r is. So we take our spinner. We know it's 8 units long. That's what r is. Spin it that far. Well, that's 135. So we spin it 135, which would be right there. So there's 8. And if this is 135, that makes this 45, 45, 90. Now we got to think backwards. Now, if we had a right triangle and we had x squared root of 2, that's how we get there. How do we get back? We get back by dividing by the square root of 2. So, to find out these dimensions, I got to divide by the square root of 2, get that square root of 2 out of there, which is 4 square root of 2. So, what we're going to have is 4 square root of 2 to the left, 4 square root of 2 up. Or if we write this in complex form, it would be negative 4 square root of 2 plus 4i square root of 2. Just slide that I in between here. It just makes better sense. Let's try this one. Same sort of deal. Here's my r, 4. Take my spinner, 4 units long. 11 times 30 is 330, which if I go all the way around there, I'm going to be left with a 30-degree angle. I'm going to get rid of that because that's just going to cause problems with our labeling. So that's 4. Finish your triangle by going like this. Remember, we said this is 30. That makes that 90, 60. These things never go away. So if that's 4, this has to be 2, but don't lose your concentration. This would be down 2, so that's negative. And then you'd multiply that by the square root of 3, and that's positive because that'd be going to the right. All right, so this is my x, so 2 square root of 3. This is my y, but it's along the imaginary axis, so it's minus 2i. And there it is. Stop the video for a sec. Hey, we're almost done. So, it says find the modulus. Remember, modulus is another word for this, which is just the magnitude, which is equal to this, which is just another way of saying Pythagorean theorem, which is just the length of your spinner. Length of spinner, or your radius. I mean, there's so many different ways to think of this. So, we'll get to argument in a minute. First thing you had to be able to do is plot that darn point. So 2 to the right, 2 up. Again, these 45, 45, 90s just never leave. So, what is the modulus? It's the length, just a fancy term. You've been doing this forever, so it's 2 square root of 2. What's the argument? The argument is how far you spun the spinner to get to that situation. Well, you can see that's 45, which is just pi over 4. 5i is a little tricky because your brain needs to put in that 0, because that's really truly saying don't move right, don't move left, just go up 5. So it's like, okay, there's my spinner, it's 5 units long. Well, technically, how far do I have to spin my spinner to get there? 90, which is pi over 2. And so my modulus, that's 5. How far do I spin it to get there? 90. This one can be a little more challenging. I gotta go 3 to the right and then 4 down. Well, this is math's way of giving you a little bit of a gift. Yes, this is a 3, 4, 5, but I'm going to put an X through it because we don't really need it. Well, yes, we do. Sorry. I was going after the argument in my mind, but anyways, this is a 5. What is that? That's the modulus. That's the length of the spinner, radius, hypotenuse. But they want the argument, which could be a negative spin and it could be a positive spin. I'll give you both. But I'm going to use these two values. Oh, I already put my calculator away. Give me a second. So I'm just going to take these values here, opposite and adjacent, and I'm going to say tangent of my angle, talk about this, is opposite over adjacent. So second tangent, negative 4/3, I got negative 53.13. So my argument, negative 53.13, that's the negative. Now if they want the positive one, in other words multiple choice, and that's not listed, fill in the blank, that's no problem. But if they put limitations, something like make sure this is true, they'd probably have it just like this. That means no negatives. So if they have something like this, this is not wrong, it just doesn't fit in that definition. So we'd have to go, all right, 360 minus 53.13. 360 minus 53.13. So 306 or 306.87. This is the positive one, that's the negative one. So just be careful of the instructions. Last few problems. Wow. Express in a plus bi form. Remember, this is a square root. We don't really care about the numerator. We need the radical out of the basement, so we're going to multiply by the conjugate. But then we have to do the same thing to the top. I'm going to take care of the top here. So that'd be 6i minus 10i squared. Remember, I squared is negative 1, so it's really 6i. Negative 1 times negative 10 is actually plus 10. Now, if we have conjugates, we can just flip, because the outside and the inside would cancel. So that'd be 9, and then minus 25i squared. That's what this times this is. So that's really 9 plus 25, which is 34. I can take a 2 out of every single one of these, so you should. And that would be my answer. If you want to get fancy, it could be this as well. If they want it in a plus bi form, I guess they're really asking for that, not this. They want two separate parts separated by addition or subtraction. All right. Last one. Can you believe it? Again, not worried about the top. I need to attack the bottom by multiplying by its conjugate. So multiply by its conjugate. So again, in the bottom, you can just fool. 1 times 1 is 1. Negative 4 times positive 4 is minus 16i squared, which is just 1 plus 16, which is 17. So I know it's going to be something over 17. Can you guys believe it? We're almost done. 2 times 2 is 2. Don't screw this up. Plus 8i minus I, and then that's minus 4i squared. Well, this right here is 7i. And then this is actually, that's a minus, isn't it? Minus 4i squared. So I squared is negative 1 times negative 4 is positive 4. 4 plus 2 is 6. Now I could leave it like that, but by the strictest sense, I think they want us to separate that into 6/17 plus 7i over 17. Guys, well done. All right. See me if you have any questions. Congratulations.